Hello, this is Jeff Hamrick at Rhodes College, and I'm going to talk for a few minutes about z-scoring your data so that you can make an apples-to-apples comparison between two different attributes of a data set that may lie on very different scales. I'm working here with the lead concentration and iron concentration data provided to us by Dr. John Russ in the Department of Chemistry at Rhodes College. Recall with me that Dr. Russ and his research team essentially obtained approximately 360 or so samples of soil from approximately 70 to 80 locations in the city of Memphis. And they used a device that they have in their lab to measure the concentration of various elements, including, for example, lead and iron. Notice as well that these two concentrations are measured in micrograms per gram and that they lie on very different scale. Lead concentrations are generally relatively low. That's good news for children at elementary schools. And the iron concentration in a soil sample is typically several orders of magnitude different than the lead concentration. So let me go ahead and shrink these two attribute columns. And recall with me that we learned recently how to create a scatter plot of data in Fathom. I'm not going to go over that again since we've been over it recently in a different tutorial screencast. But we notice that we feel that perhaps something is lost in this scatter plot because the scales of the data are not comparable to one another. And z-scoring is one way that we can create an apples-to-apples scale to compare two sets of data that we perhaps otherwise might have difficulty comparing. And so in Fathom, the way that we're going to execute z-scoring is by defining new attributes in terms of old attributes. So I'm going to create two new attributes. One of them is going to be called z-score lead. That's going to be the z-score related to the lead concentration. And the other attribute is going to be called z-score iron. And that's going to be the z-score of our data in the iron attribute. And z-scoring is pretty easy to do. Click on this attribute column so that it's highlighted blue, right-click, and then ask to edit a formula for this column. Okay? And I'm going to blow up the attributes here so that I can see everything that I can choose from to work with. But what I'd like to do is I'd like to take, for the z-score of lead, I'd like to take the raw lead concentration data, subtract the mean of the lead concentration data, and divide this entire numerator by the standard deviation of the lead concentration data. Recall with me that that's how we define the z-score. In fact, it's the data minus the mean of all the data divided by the standard deviation of all the data. So I press OK, and a set of z-scores is calculated for us. Remember that the interpretation of this particular value is that the value of 18 is roughly half a standard deviation to the left of the mean of the lead concentration data. So let me very quickly create a comparable formula for the iron concentration data. I'm going to take the iron concentration data, subtract the mean of the iron concentration data, and then divide by the standard deviation of the iron concentration data. Okay? And now I'm going to create, just so that we can take a look, a scatter plot of the z-scores. I'll put the z-score of the lead data here on the x-axis. Notice that its shape didn't really change all that much, the shape of the dot plot, because we made a scale transformation of the data. I'm going to put the z-scores of the iron data right here, and while the picture here is basically the same as the picture here because all we did is we made a scale transformation, we can now interpret the x-axis in a sort of more natural way. For example, this data point represents a location at which the lead concentration is 6 standard deviations above the mean of the lead data, whereas the iron concentration is -1 standard deviations below the mean of the iron concentration data. So this is how you use Fathom to compute z-scores.